Hi everyone, good afternoon. Thank you for joining us for another one of Ironside's Take30 sessions. I'm Pam Asgar, I'm the Director of Data Science at Ironside. I have been employing machine learning methodology in business and consulting for about 10 years. Prior to that, almost another 10 years employing them in academic research. So that's me. I'm joined today by Tim McKenzie. I'll let him introduce himself. We will be talking about data enrichment for AI, and
Precisely.
it's a strong partner of ours in that space. So Tim, why don't you go ahead and introduce yourself?
Yeah, sure. Thanks, Pam. Hi, everybody. I'm Tim McKenzie. I lead our advanced solutions team, mainly focusing on cloud native and big data processing. And we'll talk about some of the strategies that we use when we get around to enriching data. So look forward to talking through this with you guys today. And thanks for joining.
Thanks, Tim. Before I jump into the content, I also wanted to point out that today we're talking about the value and possibilities that come with data enrichment. Tomorrow, our Take30 session is going to be a continuation of this, talking more about the tactical and practical steps of actually joining that data and making it usable. So if you haven't already registered for tomorrow's session, the site is up there, so you can go ahead and register for that if you're interested. There we go. So we like to start these sessions again by reminding ourselves and you of Ironside's mission, which is to help our clients use their data to make better decisions about their business. And we do that with over 20 years of experience with end-to-end data and analytics value. Data science specifically is really a team sport, and so I don't really feel like my group sits in any one of these wedges. We have capabilities across all of them, and data science kind of pulls from each of these, which is something I'm very grateful for at Ironside, is to have those capabilities and expertise across the entire wheel, making it a very holistic approach. So as I said, we're going to talk about data enrichment. So I'm going to talk about the value of external data for AI assets and go through an example of where I found significant value. And then I'm going to turn it over to Tim to specifically talk about location enrichment with
Precisely.
And before I move on, I'll just remind you that in the chat box there's a question area. So if any questions come up throughout this, you can go ahead and type those in there, and we'll have a Q&A at the end where you can either take yourself off mute and ask questions, or I can read those questions out loud. So feel free to do that at any point while we're talking. So why would an organization look to external data to supplement what they have? If we think, first of all, about consumer analytics, and thinking about not only looking backwards and trying to make sense of the choices that your customers have made, but trying to make predictions and see the future, it's important to understand that the more holistic and well-rounded view of your consumers, the better you're going to be able to capture that and anticipate it. If you think about your database and all the data that you have internal to your organization with your customers, it's for the most part fairly constrained to your interactions with that consumer, right? And you don't need a psychologist to tell you this, but I'll tell you, humans are dynamic and multidimensional and complex, right? And so the choices that we make as a consumer are driven by a lot more than that. They're driven by constraints and stressors in our lives, by things that motivate us or things we have to prioritize, our interests, hobbies, and affinities. Now, a lot of times this is not information that you have in your historical database, but these are things that you can find from third parties, and bringing them in allows you to, like I said, not only look back and understand choices that they've made in the past, but anticipate changes and choices that they're going to make in the future. Anticipate when they might be looking to turn away from your service, or when they might have additional needs, right? Because if this last one here is really important, so I'm going to point to that. They provide services and products that meet their needs. If the information that you have is constrained to the interactions that you have, and you don't have that full 360 view of the consumer and who they are and what drives their choices, you may be missing out on opportunities to offer them other products and services that fit them. I think that is especially a use case that comes in handy with external data. So thinking beyond just consumers, locations, points of interest, when you think about trying to predict things like crime or accidents or any kind of location-based incident, the more you know about that area, properties, and surrounding areas and risks that face it, the more you're going to be able to make these predictions and enhance your AI solutions. So I'm going to walk you through an example now of where we use some third party to enrich an AI application. And this specifically we used data for. So let me set up the use case and tell you a little bit about it first. The client was a utility company, and anytime if you want to dig, you've probably seen the commercials, maybe you've had to do this yourself before, but you got to call 811, right, to get permission to dig on that site. Now, when you do that, that's going to trigger a system, a data flow to log a ticket in the utility company system. They're going to assess the risk there. And what they want to do is make sure that if this is high risk, they're going to send one of their auditors or supervisors out to that site to supervise the dig and make sure that there's minimal risk of damage. Now, those auditors are experts in their field, they're costly. And so the goal here is to minimize damage, but also to optimize those resources and make sure that you're sending them where there's high risk of damage and not where there's minimal risk. So what they have is what's contained on the ticket, right? So if you call in to get permission to dig, you're going to give certain information around the area, the location, and the purpose of it. But what we did was we built that model, and then we brought in additional data. We looked at property attributes, population density, boundaries in a school zone. And one of the reasons for that is that it's not just about predicting the likelihood of damage, but it's about understanding the consequences if there is damage, which could increase an overall risk for risks like flood and fire and distance to the coast, traffic patterns, again, getting back to consequences, and the geodemographics of the area. So we built this model first without any of that data, and it served the purpose that we had to build a model that could give you a score, a likelihood of damage happening. But then we went back and we added this data to see if this an opportunity where additional external data could boost this model. And what you're looking at on the left there are all of the features that were really drivers in this model. There were a lot more features in the model, but these are kind of the ones that had the strongest impact. Anything in gray came in on that ticket. That's information like the work type, the dig site square feet, the time of year that they were digging. And the rest of those that are in yellow, those are SyncSort data elements. So this is where the external data really helped boost the model. And you can see all of those that came in that were important. And on the right side, you see a comparison of the model results. And essentially, the bottom line is that we were able to find 25% more actual damages by enriching this data with SyncSort data. So by understanding not just the dig site, but all the consequences that go into it that could come out of it by understanding more about the property where the damage is being done or where the dig is being done. And so here, let me turn this over to Tim to tell you a little bit more about SyncSort and some of the possibilities there.
Yeah, so thanks, Pam. And I think that's a great example of where bringing in additional location-based attributes suddenly improves the predictability of a model and enhances the insights that you can ultimately even push out to the end user so that they have more information as they go out to a site. We've all seen the studies that talk about the impacts of data prep on a data scientist. And, you can see studies 60, 70, 80% of a data scientist's time is spent prepping up data. We'll spend a lot more time tomorrow talking about concepts and ways that you can better prep location data so that you're not spending so much time getting data ready for data science or an analytics exercise. So we'll spend most of our time today talking more about the enrichment, but just quickly on the organized side. So if you think about location data, it probably comes mainly in three forms. So the first is from an address. So a lot of data from a location perspective has an address, but we all know addresses. So addresses can have short versions, they can have long versions. They're dependent upon the person that entered the data, so it could be misspelled or just totally bungled up. Then we have cities that change, we have zip codes that change, and we have addresses that have all kinds of different varieties of ways of describing that location. So for instance, where I live, there's a section of Highway 92 that's also known as Old Alabama Road. Clearly you can tell I'm not based in Massachusetts, but having the capability of somehow putting some consistency to organizing address data is an important part of making location enrichment easy. Additionally, if you think about the other aspects of location, a point on a map is a latitude and longitude, but a small change in that latitude and longitude points to a completely different place on a map. Or if we're talking about a latitude and longitude on a property, do we want the latitude and longitude at the front door, at the driveway, and the center point of the parcel? So there's all kinds of ways that point level data can vary. And then when you think of shapes that describe areas of population, or as Pam talked about, areas of risk on a map, those also shapes require all kinds of efforts to begin to organize that data. So we'll talk through some methods or some perspectives that we have on ways to make organizing data easier. And then enrichment is where the fun stuff happens. So we'll talk today about the 11,000 different location-based attributes that we can bring to bear for any address here in the US. We'll try to explore a few of the use cases along the way, all in about 5 or 6 minutes. So we'll do it quick. But the end goal is to prepare a data set that takes messy addresses, messy shapes on a map, messy dots on a map, and converts it into rows and columns of data that you can ultimately ingest into an analytics engine. So that's the goal of all of this. So how do we do it? Let's go to the next slide, Pam. So the starting point from our perspective on this journey towards organizing and enriching data is to assign a unique and persistent key to every location in the US. We've done this in the US, we've done it in Canada, we're rolling it out now in several other European countries as well as Australia. But the concept here is, let's get this intimate knowledge of every potential location within the country that we're talking about. In this case, let's just focus on the US. So in the US, we have about, I actually think there's a build on this. Let's see if it happens. Pam, can you, I just noticed there's a piece. Nope, okay, never mind. I'll fill in the details. Must have lost them. We have about 207 unique locations across, 207 million unique locations across the US. And then we have a unique and persistent key assigned to each of those locations. So one way we deliver that data is what's described on the right, which is an address fabric, which is a unique and persistent key, followed by one variation of the address at that location, followed by a set of coordinates that usually speak towards the center point of the rooftop of that property. And then this would be delivering every known address in the country. The other way that we deliver this capability is through a process that we call geocoding. So geocoding can take in addresses, so any variation of an address, whether it's a perfectly pristine version of an address or a totally bungled version of an address or an old zip code with a new address, we take all those variations of an address and associate them back to this unique and persistent key and a static latitude and longitude. Likewise, we can take in a latitude and longitude and perform a function which is called reverse geocoding and associate that address back to this unique and persistent key. So once we have data from an address perspective organized to a key, then we can begin to do all the fun stuff around enriching with these 11,000 attributes. So I think the next slide starts talking about some of the examples of attributes that we can bring to bear. So in Pam's case, I think, can't remember exactly, but there were a few elements that pointed towards the people at a given property. So we have a wide variety of data sets that describe people at any given location. Some of that data is very individually focused. So we can actually tell about the individual people, household members within a household. If that type of data makes you uncomfortable, which in many use cases it might, we also bring aggregated views of population. So it wouldn't necessarily be specifics about the number of people living in my house, my marital status, my age, my gender, ethnicity, et cetera, but it might talk about my neighborhood or a block group, or but it would again give you insights at a aggregated level about the people that live where I live. Additionally, providing all kinds of ways to slice and dice and segment a population becomes easy if we have, say, all of your customer data is associated to our unique and persistent key, and we join geodemographics or lifestyle codes. Now we can easily start to categorize and segment your population of customers, or if you got a marketing list or any type of way that you want to look at or create different views of a population based upon location. Additionally, we can bring into bear details on a home or a building structure for a business. So things like, generally this would be property data that you might see at the county level. So a description of the shape of a parcel, the size of the parcel, the number of buildings, square footage, maybe bedrooms, bathrooms, roof type, things like that. You swing over to the right side from an economic perspective. So again, at a very individual perspective or at a general perspective, average income, amount of disposable income. We even have a fun data set that we provide in the grocery business and retail business around predicting the amount of dollars spent on several thousand different types of consumer goods. The amount of money on average spent on baked ham versus roast ham versus canned ham, if you're interested in that. And then as well, in the middle, we have this corporate piece, which doesn't feel like it might apply to customers, but in many cases, increasingly, we're seeing our customers wanting to better understand the amenities or the business structure around where someone lives. So for example, the accessibility to medical care or the accessibility to grocery and so on. So that's one view, which is a view from a customer or an individual perspective. Maybe onto the next page is a view from the business landscape. So understanding the types of businesses within a given area, either at an aggregate level again or at a specific level. If you're at a specific level, being able to drill down specifically into the businesses within a given location to understand the number of employees, the amount of revenue they're generating, even being able to slice and dice a population of businesses by SIC codes so you can understand the types of businesses within a given area. And if you look at location, so obviously understanding the location of a given business so that you can better understand the populations that it might serve, but also we see a variety of interesting use cases, especially in the financial services industry, around understanding, for instance, retailers within a mall, understanding which retailers you may do business with, but then also identifying, if you have a list of every known retailer within a specific location, understanding the retailers that you don't do business with today, and then even understanding or predicting the sustainability of rents if you're providing, for instance, a commercial loan to the shopping center. But again, all this data can be triggered from a location perspective. So all these insights come back and are related back to this unique and persistent key. And at the end of the day, I think a data set looks something like this next slide, maybe not in terms of circles on a map, but the concept is if you have each one of your customers or each one of your prospects, picture their name, their address, then this unique and persistent key, and then picture hundreds to thousands of attributes or columns of data that begin to describe that location and the people that live there. Anything from property details. Is this a single family home or is this a multifamily dwelling? If it's a multifamily dwelling, how many subunits are in that property? What do the people look like in that property? To business demographics, like we talked about, what are the businesses around a given location? And then who are the people that live there, either at a high level or at a generalized or aggregated view. But then the bottom is the fun stuff, and that is, so we can bring a variety of different attributes to the table for these analytics exercises, but then using our geocoding technology and some of our spatial processes, we can take in your marketing list, your customer list, any of the data that you have that has a location element, and we can enrich that and join it as well to our data in a really easy way to convert all this messy data into columns of data associated to rows that can then be driven into whatever analytics engine you would choose. So in essence, that's the quick version of how we would make Enrichment from a location perspective, relatively easy. And I love Pam's example of the value of bringing location into a model to uncover new insights that you may not have expected before.
Great, thank you for that. Really good examples. Quickly before we go to questions, we just want to summarize some of what we've talked about today. One of the points that I wanted to go back to is that algorithms are not necessarily the best way to make your AI models more accurate. Of course, we try multiple algorithms for a reason, right? Because some of them work with your data better than others and have that boost. But ultimately, the information is the same no matter what methodological approach you take to it. And so oftentimes, like in the utility example, we had already built that model, right? But wanted to see what we could do to boost it. The best way to do that at some point is to go outside of your data set and bring in more information that can enrich what you know about that site or that consumer. And so there's that value. And then also that the 360 view of customers really is what's going to bring that accuracy and ROI back to that. It's understanding the dynamics and the multidimensional nature of what drives choices and events.
Yeah, and so I think the two big takeaways from my perspective on top of what you said was this concept of being able to organize data back to a key, making sure that the key is persistent so that you can start to build business processes around that key and be able to trust that the location is going to stay the same, especially if you start to add your own data to it. And just the fact that we've got about 11,000 attributes already pre-built, and then we've got methodologies to associate your data as well back to these attributes.
Great. So at this point, we wanted to open it up to questions. I think Debbie, our organizer, can allow you to unmute. You can ask questions. You can also type them up in the chat window there.
We did get one while you were speaking before, and that had to do with the timing. So if you're developing an AI model, when is the best time to enrich it with incremental data?
Really at any point. So sometimes this is part of the plan. Sometimes when we're involved in the use case discovery and development process, sort of what Paul and I talked about last week, that's part of the plan. Things like retail site selection or property and casualty insurance, these are use cases that are really proven to be valuable with data specifically, actually. And so definitely I would hear those kind of use cases and say, we should bring this in. Other times you may have a model already built or be in the process and you want to know, can I boost the accuracy? Maybe it's just not getting there to the threshold you want. And you're looking for ways to boost that model. So our partnership actually allows for a great opportunity. We're partnered with Precisely. So we host some of that data internally. That allows me, when I'm working with a client like the utility example, to go ahead and enrich it because I have that data there, and then provide for you that side-by-side assessment of here's your model without it, and here's your model with it, and do that very accurate ROI analysis, cost analysis. So before even purchasing the data, you can get that look at what the incremental boost is. So really at any point during development, maybe you have a model that's in production and you're just looking for ways to get the most out of it. You could always go back to it. So it's really an iterative cycle, data science, and you can interject and add more information at any point. Actually, that's how most models work, right? You're never quite done. You always want to go back and see what else you can add to it. It's a great question.
Terrific. And we do have another one, and that is, if I was a bank branch owner or a restaurant franchise, how would I go about seeing who was near me so that I could use that for a data model?
Want me to take that one, or you want to take that one, Pam?
Yeah, no, I was going to say, I think that's for you to answer.
Sure. Yeah, so the traditional method has been to take what's called a radius calculation. So put a point where the bank branch is. Let's draw a circle. Say, give me everybody that lives within 5 miles of this potential location. What we're seeing in the industry is a growing interest towards understanding two things. One is travel distance versus straight radius. So we all know, and we can all think of places where, for instance, a business is located beside a river. Well, just because people are within a mile of you doesn't necessarily mean, if there's a river in the middle, that it's going to be easy for them to get to you. So we are seeing an increasing number of use cases where folks are using drive time analytics. So building what we would call isochrones, which an isochrone is, if I travel in 5 minutes or 10 minutes from this bank branch, what's the shape on a map look like around that location? Or isodistance, which is if I travel 2 miles in any direction, what's that shape look like? And then aggregating the population that falls within it. Some of our more sophisticated users are beginning to go kind of crazy with this and do things like, okay, if a bank branch is in a shopping center with a laundromat, with a coffee shop, with a 24/7 workout facility, and the bank, typically those types of businesses draw a crowd from a smaller geography. If the bank branch is sitting in the parking lot of a Costco, that suddenly there's a much bigger population that'll actually travel to a Costco than would travel to a laundromat. So we can start to look at ways to build and adjust those travel times to better understand the population that would come into play for a location. And then layering on all the mobile trace data sets that are out there so that you can understand populations that are actually driving on the roads around it. It's another way that folks are looking at.
We do have another one, Pam. Do you want to ask it?
Yeah, I think this is for you, Tim, as well. Where does the data come from? How's it maintained and kept up to date? Is it better than, say, the Hertz GPS data?
Sorry, say that last one.
Is it better than, say, the Hertz GPS data? How would it compare?
Gotcha. Yeah. So it depends on the data set. So when we talk about our unique and persistent address data set, the 207 million addresses, we're actually sourcing that data from 10 different sources, got a variety of algorithms that ingest that data on a monthly basis, then have the smarts to recognize when we see a new address. Our POI data, which is the public places data, where I talked about a couple use cases around pre-scoring amenities, based upon a location. In the US, that data set has about 30 million businesses. That's sourced from 4 different sources, from anything from mobile check-in type data to business listings data sets. We've got an aggregator of data from state, what is the business licensing bureaus at different states. In regards to mobile data, which I view the Hertz GPS data as a mobile data set that's telling you about the paths of travel that a given person may take. Today, we don't really provide that data as raw inputs. Instead, we're using data sources like that to augment or add columns of data to describe a population, or where does this population generally travel, or what types or how many people generally travel by a given POI. So we would probably view that as we're more of an aggregator of data sources instead of a single provider of any of these data sources. Good question.
We have one more question, and we're also at the bottom of the hour. So let me just ask the question. We can give a quick answer and then wrap it up. Actually, how frequently is your social data updated? And do you have anything with respect to about the college kids coming home and the social data around that?
Interesting. Yeah, so social data is two different ways to consume our social data. One is through an API. So in that method, the data is updated, I wouldn't say daily, but at least 3 to 4 times a week. We're getting refreshes, probably depending on where you're the addresses that you're looking at. So that data is relatively updated. The other way is that we do data dumps, so to speak. So every person within a given area, because we build those data sets on a monthly basis, so you're seeing an update once a month on that data. Interesting use cases for sure around college kids and their movement patterns, especially over the last few months. So being able to start to see kids who would traditionally be associating their location or doing check-ins at locations around their college campus are now doing check-ins, hopefully not too many, but doing some check-ins closer to home. Our social media aggregators are able to now better understand where those college kids have migrated to as a result of the craziness going on right now. So that, yes, in those data sets, you'll certainly see those movement patterns.
Thanks, Tim and Pam. We should probably wrap it up.
Yeah, great. Thank you all so much. Again, we'll extend this conversation tomorrow at 11. So thank you all for joining. I hope you have a great afternoon. Take care.
Thank you.